So in order to add or subtract fractions, you definitely need a common denominator. However, to get that common denominator, I would first want to factor these denominators. Now, the fact that I have a trinomial and it's quadratic leads me right to my first graphing calculator MVP most valuable program, Factor. So let's go ahead and go to program number 1. We'll type in these coefficients of 2, 3, and negative, make sure you use the negative key, not the minus, 27, and it factors it for me. So I'm just gonna cross out this denominator, rewrite it as 2y plus 9 and y minus 3. So now for this one, because it's not a trinomial, we can't use this program Factor. Factor is specifically for trinomials. So instead, we're gonna wanna go to page 33, which is side 1 of our math reference document. And that first image is the 6 different factoring scenarios that you'll ever encounter. And the one that we're actually dealing with is scenario 3, which is a binomial with x's, which really is the greatest common factor scenario. So when we take out the greatest common factor, which ends up being 3, because 3 goes into both, and then you always pick the smaller of the two exponents, so y to the first. So let's go ahead and see how that plays out. So let's rewrite this first fraction. So we have 4y over the product of these two quantities that we got from our factorization. Now, whenever I see minus, I actually like to change it to a plus and put the minus in the numerator of the next fraction. However, I'm going to make sure I put parentheses so I don't forget that I eventually need to distribute that negative. Now, when we take out the 3y, let's see what we're left with. 3 goes into 6, and then I basically subtract the exponents, so it's y to the first. And then I have plus, the y's cancel, and 3 goes into 27 9 times. Okay, so now for my common denominator, every single part of each denominator needs to be accounted for. In other words, this 3y monomial needs to be part of the common denominator. So these both have 2y plus 9, so that's going to be part of the common denominator. If they had differing exponents, you would always pick the higher of the two as the common denominator. So for example, let's say you have x to the 5th, x to the 2nd, you would pick x to the 5th as the actual common denominator. So at this point, we also need to account for this y minus 3. And officially, we've accounted for everything, the 2y plus 9s, the y minus 3, the 3y. So now we can say, well, what is this denominator lacking that's in the common denominator? Well, it doesn't have that 3y. So I'm going to multiply top and bottom by 3y for that fraction. And then for my other fraction, the only thing that I don't have is the y minus 3. So I'm going to go ahead and multiply top and bottom by y minus 3. So when I multiply these two monomials, I get 12y squared. I have this minus, which I'm still going to keep here. And then when I distribute, I get y squared minus 3y plus 1y, which combines to negative 2y, and then minus 3. When we distribute the negative, it flips the signs of everything in the parentheses. And now, if I combine like terms, I have 11y squared plus 2y plus 3 in the numerator, which matches with option A, and all the denominators were actually the same anyways. So that gives me my answer, A.